right? It will look something like this. Okay. Yeah. So this is your they give you some starter code lah. Okay. And this is the registration of CBP. Okay. CBP is the code blocks project. Depend is the dependency for the project. Okay. How all these are linked. And then of course layout is also for the code blocks itself. There's nothing to do with source code. These three, even if you don't have an open Visual Studio Code, and then still be able to run the web program. Okay. Then of course, there's a bin and the object folder. Okay, the object folder contains previously compiled programs, pop classes, files, and then after that you link it to produce registration.exe. This one may not run. You can see it doesn't really run. Okay. Let me just see again. Let's see why it doesn't run. Yeah, so it doesn't really run. Okay. So normally we have to compile again. Okay, to make it run. Okay, it doesn't run maybe because of some missing libraries and stuff like this, and it doesn't flag out all these errors. Okay, so I'm going to use the code blocks to open the project. So for opening the project, all the files are actually open. Okay, so if you find that distracting, then just close everything by right clicking on it and then pause. Okay, so that will come. Okay, on the left hand side of the workspace, you see that there are 5 files: main.cpp, pause.cpp, register.cpp, pause.cpp, and register. So normally the first file we read is main, then subsequently we'll look at the page file, okay, that will be easier. Then for implementation into the CTP files. Okay, so our first job is to come up with the overall high-level algorithm for main. Okay, in your assignment, you are supposed to do the high-level algorithm for uh, every every method that you see that's important. Okay, for this case here, we are just looking at main. Okay, let's open the main. Okay, and you can see a lot of helpful stuff. Okay, my helpful is meant to be sarcastic. Okay, because it clutters by view. I don't like so many comments. Okay, maybe it's if it may be your type that you like, but one man's meat is another man's poison. What appears good to you is poison to me. Okay, so I don't quite like all this because it's cluttered. Okay, but anyway, first thing you realize is that not so it's subtle, but you realize that if you click on any of the line that's indented, you'll find that it's actually wrongly indented because you see that it's actually one and two pages. One and two. Okay, typically in your Java program, Python program, it's all 4 pages. And the universal standard is 4 pages. Okay, so let's deal with it. And on any part of your code itself, you can right click and then click on format use A style. Okay, so that will bring us the code to be properly indented 1, 2, 3, 4, 1, 2, 3, 4. Okay. Yeah. So that's the first thing I'll do. Okay. Then of course the second thing I will do is to get rid of all the excessive commands. If it's not excessive to you, it's definitely excessive to me. Okay. So for you, because you are a student, these are all meant for you. You can read first, then you delete. Okay. For me, I'll just delete. I read it many times. Okay. So this one can throw. Okay. And then it tells you do the hidden first. Okay. So okay, this one can throw. Okay, this one can okay. Then it explains to you what is a namespace. Namespace I already mentioned to you before. It's a package. Just think of it as a directory that stores all your codes, whether it's classes, whether it's structs, whether it's functions, okay? And it belongs to that particular package. Um, the thing here is that sometimes we don't want to use the entire package because when you use the entire package, certain functions we don't want to use will be exposed. And certain functions that we don't want to use, but we want to use our own name, it may clash with the name, namespace function name. Okay, so that's why it's not recommended to use the entire namespace. Okay, but nevertheless, we will use it now like that. Okay, I'll delete this, and then I'll delete this. Okay, then the next thing here is um, it says create the high level algorithm for the main program. Correct? Okay, but if you look at these comments over here, this is essentially the algorithm. Okay, that brings us another question. Are we talking about the algorithm or are we talking about
pseudocode.
so in the course here, whenever you refer to algorithm, it's actually talking about pseudocode. Okay, so you need to know that when you ask you to come up with algorithm, you need to use. Okay, so for here we just uh you see this is the algorithm, right? Number one, open the name file. Number two, right? Number two, display all the information. Number three is calculate the total. And then number four is write listing per file stream. Okay, if you look at this, this is the algorithm. This is step by step. Can I say that? It's a recipe of 1, 2, 3, 4, right? It's an algorithm. Okay. So what he's really asking for is not algorithm. He's really asking for
Pseudocode.
pseudocode. And in your chapter one, I think he came up with this algorithm syntax, right? Look at the folder. If you have for those students who have, if you go and read download again, the folder that's algorithm syntax. Okay, and he's expecting you to write something close to this. So that you'll see in chapter 7 again. Okay, the algorithm style one. So this one is actually referring to yeah. See, algorithm style. Then it says use the pseudocode notation given in this. So it's a bit confusing, but just know that whenever he says algorithm, it means pseudocode. Pseudocode means pseudocode, algorithm means pseudocode, right? So it says use the notation like and or not. Okay, instead of n%, use and or not. Logical comparisons, you can use this to follow the very similar C++. When read full numbers from keyboard, okay, this is the way to read. Write this way, write to the screen, okay, and then of course open the file for reading, open the file for writing, okay, and if and else, okay. Okay, that is what he wants you to do. Okay, that's what he wants you to do, right? And you are still not sure, unfortunately, you don't have access to it yet. For some of you who have access to this, okay, this is lecture 19. The type of pseudocode that he's asking you to write will be something similar to what you see here. Something similar to this. Okay? So this is the pseudocode, the algorithm that's asking you to come up with. Okay. So okay, knowing the objective now, knowing that this is our objective. Okay, we go back here, okay, and then of course try to understand the code a little better. Okay, so first of all, you read the code. IF stream infile R input of text. Then it tells you infile is an object of the run stack, but doesn't give you too much of information. And after that, it tells you R is an now an object, like what you did in ICT187, blah blah blah. Again, it tells you the low level thing, but it never tells you. Hello, please. Who's there? Yeah, can you silence your mic? Okay, so um, here we will erase this. Okay, take away this. Okay, then it tells you this is a subroutine call. You can go and read it yourself. Huh? Okay, subroutine call, second parameters, blah 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 blah. Then after that, from inbound loop to R. Okay, so yes, this is the correct thing. But never mind, we just okay. And then use the debugger behind the scenes. Okay, you need to use the debugger, but for now I'm not using. Okay, and I think okay. So far, I've deleted many comments, and if you try to compile, it will not compile because there's one line here that fails, right? So this one you need to take out or need to comment off. So by now you should be able to comment. So for the okay, we can't comment is because of the object files that's inside the OBJ folder. Remember just now I showed you, right? There's an OBJ folder, right? This OBJ folder, right? Okay, these are all the full object files that may not be suitable for the system. So you need to clean the system. Then after that, recompile and link your libraries. Okay, and then you should be able to run. Okay, and okay, right. So of course, if it's a program given to me, the first thing I would want to know is how the program actually works. Okay. Um, but before we go to that, okay, see, this high level I think is easy, but then okay, let's look at the code again. So you can see that this IF stream is called the input file stream. Input file means to read. So this in file is the object, okay, that is created after you read in this particular file. So you can see read file as in file object. Okay, and this part here is to check whether it's readable. It may not be readable, maybe because the file is not there. It may not be readable, maybe because okay. Yeah. So in the case whereby you cannot open, right? So if file is in file is unavailable, right? Then we this one is to exit. Okay. Okay. Next thing here is the registrations are okay. Okay. Unlike Java, when you do this, R is um object that's straight away created. You do this in Java, it's only a declaration. Or you do this in C++, and object is created. There's a huge difference. Okay. Okay, and I don't quite like the name because you need to name it properly. So I will right click on this. Insert refactor, rename symbols, and then this as registration object. Okay, so if you name it, if you highlight properly, name it, you can see that all the big R's are now changed to registration object. One, okay. So naming is important, especially when you work, do programming on this. All these are actually important. Okay. So we can see that this part here is to create a registration object. And upon creating the registration object, you're actually reading in, right? Read from file into registration object. Okay. Yeah, read from file and then push it to the registration object. Okay. And this part here is of course to open the file, right? Open file for writing. Okay. And here this part is to simply write back to file using this operator from registration. Okay. So again, we will talk about that later on. Okay. So typically the whole program, if you look at the main, even if you don't see the entire code behind, you can already tell that okay, I am reading from the input file of text, push it to the registration object. After that, I use the registration object and write another file. Okay, so that's the short overview. And then why are we doing that? Okay, so since you roughly know the idea that we are reading from input and writing from output, that means our objective is to see how the output file will be different from input file. So we go to the directory. Okay, after we compile, we run already. Right, you can see the timestamp is 7 p.m. I run it just now. Okay, this is our input file, and this is our output file. So you can see that, oh, okay, I am simulating taking from what we call a raw data, and then formatting it something that is like a report. Okay, so I'm taking raw data, text file, and then format it report. So that's basically the objective of the program. Okay, as for the nitty gritty details, we don't need to know yet. Okay, so all we need to do, okay, all these have nothing to do with the above, so I can actually command them off now. Okay, and if you simply want to indicate that the program is complete, I would also put this way end of program. Okay, sometimes it's good to put this because if something crashes, you don't see the end of program, you know something is wrong, right? So file that you run, you can see that okay, now everything is run. Okay, and the other thing is to look at process. Process returns 0 is okay. All right. Okay, so now our job here is to write the main as a high level algorithm. So that means if we follow this format, this is the function, and this is end of the function. And then we try to write the format if and else, something like this, while something like this, together with the notation given to us in the algorithm style as we see over here. Okay, right, okay. So let's try to do that. So we start off with main. and then we end main. Okay, so this is our function name, main and end main. Okay, so a couple of stuff we already written. So these are comments for us, but we know that we are going to write it as an algorithm. So we follow the algorithm style just now. This is to read the file, input file, and in file. So if you look at this, it says open read in file equals to this. Okay, we just follow. 1, 2, 3, 4. Okay, lines 18 to 20, we don't have to write exactly like this. If you write exactly like this, that means you don't know what you're doing. Okay, so in this case, I know that you can write if not in file as what it says. You can also say that if in file is not available, okay, then return error code and exit. Okay, so pseudocode is not exactly code. So we shouldn't write it so much like C++. We should write close but not so much. Okay. Okay, then for this registration object, so how do we declare this, right? In the pseudocode over here, you can see that he does declare it like this: boolean subset equals to true. So this is a boolean. Okay, he does declare it this way. So for us, it's a bit of a problem in the sense that registration is not something that is common in like Boolean, like not integer, not float, not something like that. Let's say somebody is seeing this the first time. How do you put registration? So we can add one more keyword. Declare registration. Okay. Okay. Registration. Or create, not create registration. Because you're creating. No, okay, after which you're supposed to read from the file. So this one's quite easy. Just read from in file to registration. Okay. Yeah, so far it looks line by line is because the codes are already so-called well structured. If let's say some of the codes are multiple lines, we don't have to go line by line all the time. If by doing so, if let's say there's many lines, you don't do line by line, it shows that you don't know how to do it. Summarize sometimes. Okay. So okay. So far it's all line by line, right? 1, 2, 3, we are following line by line. Okay, but in actual pseudocode, we don't have to do that all the time. Okay, for now, yes, we still need because it's like I said, it's really very short. Okay. So for the open write file, okay, write out file equals to r output of text. Okay, and the last one is just write to o file from registration object. Done. Okay, you see the last part I actually ignored. That's good. Done. The extra things like 33, all these not part of the requirement. No need to put. You understand? All for my debugging. Okay. Okay. Can we continue?
Lot
A lot of what
of
error?
but my build field
Or do you clean your book?
following what you did just now.
Your build and clean.
Yeah, I press build. There's like
Cannot be what? You comment off the line.
I followed when you start, but the top like nothing much. It's just comments. So everything else I follow.
You build clean first. Clean again. Yeah, clean. 那当你发你错别字的。
Not just click.
哇，
Okay, thank you.
Yeah, you need every time it doesn't, you think your code isn't wrong, but it doesn't build, you need to clean. Okay, some of the files actually hold, they cannot link. Because compilation, they take the object files and link them together to build, to create your executable. Some of these link files, these code files, they are not suitable for a system because they built on another system. Okay, right there. Right. So with that, we have completed the high level algorithm, right? So that's our first thing we want to do. That's the first thing we want to do, right? So that's the first thing we want to do, okay? Then for second thing we want to do is of course to understand the program and draw the UML. So for now we will take a short break. Okay. Once the break is over, we will do this because we will take some time to understand the program. Then of course draw the UML. Draw UML quite easy for us. Okay, so we'll stop here. Let's be back. I think give you all 10 minutes, okay, right? Okay, go and read up. Okay, so of course the first thing we should, okay, there's a lot of things wrong with this program, okay? Not because it's technically wrong, it's because of the naming convention. That's wrong. We will talk about that later on in one maybe the next step, okay? So the first thing of course we should read is always the main. Main is the starting point of the program, and then we should follow the program. So the program overall, in terms of the it is actually quite easy. Okay. So we read the file as in file. If not available, exit the program. Then after that, create a registration object and redirect the file contents to this registration object. Okay. So after which you open a file for writing, but again, we need to understand what happened over here. So that's the first thing we need to understand. Okay, so we open up our registration.h to look at the registration class, and you can see that the registration class has lots and lots of things that ask you to read. Okay. Okay, and okay, so this part here you can read on your own. I'm going to delete. I cannot stand a lot. Okay. And this one here you can read on your own. So all in all, the class is just like that. You look at it. So not too bad, right? Okay, not too bad. Okay, of course the indentation is wrong. I would like to fix it first by using a style. So it's actually fixed. Okay. Then we look at the overall class and see. The first thing, of course, we will see is the attributes, right? The registration class has 4 attributes: student ID, semester, count, and an array of 10 course objects. Okay. Registration constructor, get credits, get count, and then the output stream operator and the input stream operator. So when this one is called, you are actually calling the registration constructor call, right? This automatically called. So we look at the regist.cpp and we find that we find that the thing that has initialized is how it goes. Okay, but typically, what do you do in a constructor? What's the purpose of a constructor? Initialize, correct? So what has the constructor not done? The constructor has not. He has only initialized what? Count, right? But what about student ID and semester? Not initialized. In Java, you can do that, right? In C++, you cannot. Okay? In Java, everything is 0. In C++, everything is undefined. Okay? So we need to initialize these two inside the constructor. Of course, I'm not going to do it now. Okay? I'm just telling you can do it yourself. Then we do it that way. Okay? So you need to initialize these two. And this one, I didn't say about this one being initialized. I say you should initialize these three, but not this one. I never say this one. Why? Because this is already created. Like this means you create the array already. There's no need to further initialize. In fact, you cannot. Okay, in fact, unless you are using a pointer. Use a pointer, then you will create a dynamic array. But in this case, you cannot. Okay, so therefore, this is already created. We need to initialize these three. Okay, so that's one of the problems there. Okay, then of course, when we redirect this, that means after we call the constructor, you redirect the contents to registration object. Okay, we open up the R input, okay, and see these details over here. Okay, and then we follow the flow. Okay, scroll down. Okay, this is the input stream operator, and when we first do input, that means you are taking from a file. The cursor starts from the first byte, 0 byte, okay, and redirects these contents to R, which is a registration object. So r.student ID. So that means you read the first token, this token, into student ID. Alright. Okay. After that, after this redirection, the cursor, the file marker will stay here. Look at where is it? It stays there. Okay. So you redirect the next content to r.semester, which is an integer. So it will skip all the white space in between. Look at the next token, and then read this, assign this to r.semester. And after that, the cursor stays here. Okay. And then the last one, of course, you read to count is an integer. Skip the white space. You can have 1000 white space, doesn't matter, you skip everything. Okay. And then you read the single number, and then the cursor will stay here. Okay. And after this line 28, the file marker will stay here. You have read until this point. It will be before the next line, before the new line. There is an invisible character new line which is in the back. Okay, so it will be for the new line, right? And we read the count as number 4, and now we can read this. For unsigned I equal to 0, I smaller than 4. That means this is going to loop total 4 times. Okay, one more thing to remind you, if you read the FAQ, all unsigned are to be changed to integer. So in C++, we will use unsigned. Okay, so this part here, I like to cut it, paste it. Okay, it will make the code clearer. Okay, so that you know that this is part of the for loop. Okay, so go back to here again. Okay, so now we're going to loop a couple 4 times. So this input direct to R dot costs. R dot cost is actually cost object. So which means that we need to look up the cost. Okay, so looking up the cost object, we look at cost of uh cost of H. Okay, okay, so the cost object um okay, the cost object has a C string. This is a string. This is a name which is a string. Okay, cost name size 10. That means it's actually not size 10 but 9. Okay, I'll talk about that later on again. Okay, character section. So one string, one character, one integer. So you look at the file format, one line is equivalent to one cost, as you can see that. So this is string, this is character, this is the credits, the integers. Okay. So it looks like it's going to map 1 to 1. But of course, in order to be sure, we need to look at the operator input stream. So we go to the cost input stream, and then you can see that indeed, once we are here, if loop into the cost, you will direct c.name. So you will skip the new line, read this, and then pass to c.name. Okay. Then goes to c.section, skip the white space, read C, pass it to section. Credits again, skip the white space, read number 3, and then stop here. Okay. So I'm very precise one by one how where the form marker is for a reason because later on when you read, you're going to read one whole line, you realize that certain parts are not being removed. Okay. So you loop this a total of 4 times, right? By the end of the 4 times, you will have read into 4 different courses your cursor will be here. Okay? Good? And
What does unsigned mean?
unsigned means it's a positive integer. But in the course, it wants you to use only integer. Just use integer. Yeah. I think there was reasons why not to use inside. That explanation given. There's an FAQ. Is you do not precise one. Okay, so you understand how the thing actually works now. So we know that you read, it becomes a registration that you populate the student ID, the semester, the count, which are the 3 attributes. Then after that, by looping a total of 4 times over here, you are populating the array of courses. Alright? So that means all of them are now completed. Okay? So registration is complete. Okay. So we go back to the main. So that means after that loop itself, the 4 iterations, we have finished reading the file. So we open a file for writing. And this part here is using the output stream from the registration object. So you go back to the registration object, you can see that it's the same, just the opposite. Okay. So you can see that this one directs, okay, directs the student ID and then put its own attribute student ID, semester and r.semester. If you open up the r.output file, which is this, we can clearly see that, okay, these two lines are here. Okay, and then you need to look a total of 4 times because of the count, and you can guess that all these comes from cost, right? You can roughly guess that all these come from cost. You go to cost itself, you can see that these are all from the cost. Okay, cost of name, section, C, credits, fee, right? So a total of look for 4 times. Okay, so after you look 4 times already, this is done. You go back to registration of CPP. Okay, this form is done, nothing else. That means, where does this two come from? So this two is not part of the registration class. As we can see, it actually comes from name. You wrote this over here. Okay, so now you know how the output actually comes about, right? Alright, so the input stream, output stream, the good thing about overloading the input stream and output stream is that the input stream, the output stream you can actually print to the screen of the cloud. You don't have to write twice. In C plus in Java you can't do that. You need to write a method to print. Right? Okay. Okay, so that's the explanation for this this over here. So to test our theory that this is correct, what we've interpreted, that means if I make changes to the input file, I should see a change in the output file. Okay, so let's change the student ID to 55667 and the semester to now it's what semester? GA. Oh, this one must be. So I just got 888. Okay. Then we increment the number of subjects by 1. So we add one more subject, physics. Okay. So we close the output file first, we run. Okay, program shouldn't change because the input file is the one that's changed, right? We run. And then you look at the output file. Yeah, change accordingly to what we did. Okay, so that means our theory actually works. We know that this is what we key in, and this is what we get. Semester has changed as well. Then of course we added one course, physics, and the number of courses now is calculated as 5. Okay, all good. Simple. And right. Okay, so one last thing to do. Okay, one last thing to do, that is your UML. Okay, your UML needs to be determined from the program. Obviously, the first thing you read is of course the main. And then the main itself, there's only 2 classes, right? Main is not actually a class. And then it makes use of registration object. And the registration object, if you open up, it composes of up to 10 course objects. Okay, up to 10 course objects. Okay, why is it composition, not aggregation? For sure, it's composition, not aggregation. The reason is because this is not a pointer. If it's a pointer, there's a chance it will be aggregation. If it's not a pointer, that means these objects are actually on the back. When this registration is created, this will automatically be created. When this one is gone, it must be all from the memory stack. So therefore, this one will also be destroyed together with the registration. Okay, so this is a composition. So we look into the cost of H. Okay, we find that this is a plain vanilla class. Okay, plain vanilla because this is string, a character, and integer, nothing complex. Okay, so let's bring up our star here now. This is your need to change. It's not. Let's okay, so to take the default approach, okay, eh, okay, so I add in a main, although it's not class, add in registration, add in cost. Okay. Okay. The thing here is that the relationship, okay, as mentioned before, you only need to focus on five: aggregation, composition, generalization, dependency, and realization. Only five. Okay. Okay, definitely between main and registration, it cannot be parent and child, neither is it composition. So that gives us only one relationship or dependence. It doesn't depend on you. Correct? It makes use of the registration class. But we know that the registration composes of the cost. Okay? And that means that I need to use the composition itself. Remember, the diamond peak is always at the container side. So the registration contains cost. But because it is an array, and logically speaking, a registration can only be valid if the student registers for at least one course during that semester. Doesn't make sense for you to register for the semester if you are not in course. Which means that you need to have at least one course in the registration up to a maximum of 10. That's what we see. So hence, we need to click on this and then type 1.10. And this is all. Okay. This is what we call the high level diagram. So I need to add in the annotation and call this like registration at high level diagram. And of course, change this to a larger one. And then of course you add in your version and okay, your legend. And this is high level. You alright? Okay. Of course, in your assignment, you are supposed to produce both high level and low level diagrams. Okay, let me save this. Okay, I've already done that previously. So just double click and show you. Yeah, so the low level is not does not include the relationship. Okay, my low level is also incomplete. I did not put in all the methods for registration. Neither did I put anything for the course. You complete it yourself. Okay. Okay. Any questions so far? So today, all in all, we have touched on algorithm. Okay, algorithm you need it for your assignment. You probably need it for your exam. Okay, then we also look at the high level diagram, low level diagram. Those are definitely needed in assignment one. And exam, you need to understand because you will need to help from the UML diagram sometimes when you come out with exam. Okay, so these two gone through. Also, we went through the understanding of the program, how the input stream, output stream operator works. Okay, you should go back then try to read up lab number 3 before you come for class. Okay, I said I would end it early, but of course, as still say in class, not asking you to sleep, so that you can continue working on your question 1 of lab 1 for submission. Okay, so that's all. Any questions you can stay there and ask. For the next class. Okay.
Okay.
Okay. And
Thank you.
any questions before I stop the sharing on?
So for the lab one, we also just follow suit that algorithm. So we don't do the algorithm. Because the last week one, we are supposed to do the document, right? The test code is for
The test code on
There is algorithm.
you mean that for
the submission. Yeah.
this one?
So the algorithm we just follow suit what
You mean the format?
Yeah.
Yeah. You can do that. Points and
Just to double confirm the structure chart is not the one that you put on the different one.
structure chart.
Then the next submission will be the lab 4 one.
Submission, this submission you like.